Hi everyone, it's Joe Drumgoole here, and we're going to start the Back to Basics webinar in the next couple of minutes. This is part 2 of a 6-part series. I do encourage you to register for the subsequent episodes if you haven't registered already. We talked in the previous episode about a number of specific things. Firstly, why NoSQL exists. Why did the world have to change? Well, primarily our demands that we make on data and the speed and rapidity of development have asked things of relational databases that they're unable to answer. This is the reason that NoSQL exists at all. The requirement to handle millions of mobile applications, to change your data formats based on changing requirements, is what drove the development of NoSQL databases like MongoDB. We then talked about key value stores, graph stores, wide column stores, and document stores, so that people would understand the full taxonomy of the kinds of NoSQL databases you'll come across. And then we focused on some of the key features of MongoDB. And we finished up talking about 2 key aspects of MongoDB that will become very important as you move into production: the use of replica sets for durability and the use of sharding for scalability. And so if you can only remember 2 things from the first webinar, it's that in order to get data durability, we make multiple copies of the data, and those copies are automatically kept in sync by creating a replica set, which can have up to 50 copies of the data. And those copies can reside anywhere you want on the network that has network connectivity to the primary. Secondly, to get scalability, to effectively allow you to run multiple replica sets in parallel with multiple primaries, we offer sharding. And the key aspect for both of these things, it's fully automated and fully managed by MongoDB. We'll talk more about these 2 aspects of MongoDB later in the day, or later in the series of webinars. But for now, we're going to talk about effectively your first application. We're going to talk a little bit about what it means to have a database in MongoDB, how to install MongoDB from scratch, and I do encourage you, because this stuff is interactive, do take these steps with me. Now, I'm working with OS X, but I would encourage you to try out the things that I'm trying. They're all relatively small scripts. You could nearly type them in on the fly or cut and paste them. But do try out this stuff with me, because that will make it a much more successful experience for you. We're then going to build a really basic blogging application. We're not here to build brand new software or reams of software today. We're using the blogging application to just give you effectively the experience of working with MongoDB and doing the basic things that everybody needs to learn to do to be effective in building with any database system. So the create, read, update, delete operations. Then we'll move on to an important area, and again, one of the challenges we face with brand new MongoDB users is they forget that this is a database just like any other databases, and one of the ways that we get performance out of databases is by judiciously adding indexes. And of course, once you've added an index, you want to make sure it's being used. So we'll show you how to use our query analyzer, the explain module, to understand that an index is or isn't being used and where your performance is being soaked up inside the application. So let me just remind you of the way that we map from the relational world you know to the MongoDB world. Well, MongoDB has databases just like relational, and you create them and delete them and manipulate them with a language pretty much like SQL. In MongoDB, we have collections instead of tables. Why do we call them collections? Well, because the documents that we store in collections can vary in size and structure. A table intrinsically implies a rectangular format of the data and a fixed format. A collection is generally more amorphous, and it communicates more effectively that what we store inside a collection is an amorphous collection of documents that can change in structure and size. Similarly, rows in tables in relational databases are fixed format. A document can vary in structure, can have nested objects. Those of you remember from webinar 1, we showed some documents with nested formats. You can have arrays embedded in documents. You can have other documents embedded in documents. Indexes are almost exactly the same. We have indexes in MongoDB. They're B-tree-based indexes, just like most relational databases, and indexes are created, applied to collections, and you can set up the indexes in various different ways to set up most efficiently the way that you query your data. This is a new addition. So I did this presentation a year and a half ago. We didn't have joins in MongoDB. This is a feature we added in 3.2. It's called the $lookup operator, and it does effectively a left outer join. We're going to talk more about this operator as part of the aggregation framework talk. So I won't talk about this today, but you will see more conversations about this in subsequent talks. I think this is talk 4 is the aggregation format talk. Foreign keys are something that relational databases have historically depended on to give you relational and query integrity across your database. They turn out to be a way of crystallizing the way the world used to be. And one of the biggest challenges that we face with a large relational application is discovering that the foreign key relationships have to change. And the challenge there is, what do we do with the old data? Well, in MongoDB, we don't have foreign keys as something native to the database. Instead, what we do is we just use simple references. So the references are essentially created and maintained by the application. And you'll see an example of this as we work through the slides. In relational, one of the key values of ACID is the idea that we can do multi-document transactions, or multi-table transactions, I should say. So the ability to essentially run updates on several tables and have them see a single transformation in one point in time. We don't have transactions across multiple documents or multiple collections, but each update to any single document is guaranteed to be transactional. So if you have 50 updates happening to a document in parallel, they will guarantee to be serialized over that document. So you can use that property and the find and modify query that we provide to essentially create multi-table or multi-document transactions inside your application. Again, we're not going to see any of that work in this talk. This is very much an introductory session that allows you to understand how you can do your first steps in MongoDB. So let's just install MongoDB from scratch. Now you can go to the download page, just type MongoDB download into any Google search page. I've given the URL here, which essentially gives you the download for the community server, and you can use curl or wget or whatever your favorite download tool is. And this will come down pretty quickly. And I just wanted to take you quickly through the programs that we have here. I mean, it's not a huge stack of software. This is what makes MongoDB so powerful. It's actually very straightforward. So we've got Mongo dump and Mongo restore. These two programs are essentially command line tools to take a dump of your database and restore it in binary format. It actually stores the binary format as what we call BSON, binary JSON. Then we've got Mongo export and import. This is, again, to pull data in and export data out in a format that's interchangeable with other databases, typically CSV format. And so you can use this to load tabular data from relational databases, from Excel, or from any other data source that understands and can generate CSV files. Mongo Stat is effectively a program that will give you an insight into what's happening to the database in live, and I'll show you an example of that running later. So Mongo Stat tells us stats on what's happening to the database, and it reports on a second-by-second basis. Mongo Top tells us the top queries that are operating on it. BSON Dump will essentially take a BSON object and dump it in text format. So if we want to look at effectively a file that's been generated by Mongo Dump, we can dump it in BSON format. Mongo Files just generates a set of file data. The oplog queries the oplog. Again, it's for replica sets. Perf is essentially testing the disk performance of the system. Sniff allows us to look at the on-the-wire protocol. And then MongoD is the main daemon program. MongoD is effectively what we run when we start MongoDB for real, and I'll show you an example of that running in a second. Then, if we're building a sharded cluster, we use MongoS, which is our shard router. We won't talk more about MongoS today. We talk about that later in the sessions. And then Mongo is the Mongo shell. This is the command line environment that we use to effectively interact with the database on the command line via JavaScript. And I'll show you some examples of that straight away. And typically once I unwrap the Mongo binary, what I'll do is it creates this version directory. And what I should do is I will link to MongoDB. So on my own laptop, I have obviously several versions of MongoDB running because we support everything from 2.6 to 3.2. If you're downloading MongoDB today, you should be downloading MongoDB 3.2. That's the most current version. And just go to the download page and it will offer you a platform based on the platform it detects for your download page. So now we have a directory with the binaries installed. What's next? Well, we need to start the daemon. So before we can do anything with the database, we need to start the daemon that will accept connections from the database. This is a distributed system, so the client programs that you write will connect to this MongoDB daemon over a network connection using SSL and TCP/IP. So there's a bunch of things you'll see that the daemon does. So it tells you what version it is, which is 3.2. It tells you what ports it's running on and the PID. It also tells you the DB path. So I've picked a specific DB path here. So if you look just here, oops, I've overwritten it. If you look just here, there's a specific DB path there that I've picked, and this just isolates this test set of programs from other databases that I've stored. Then there's a specific thing we'll see here, detected data files. So we support two MongoDB storage engines by default, mmap v1, which is the original storage engine, and WiredTiger, which is the new storage engine. So once you start it up, it will look in this directory data b2b and try and work out what kind of data files are in there. So because I've been using this directory already today, and I've been creating WiredTiger storage engine files, it knows that it's a storage engine WiredTiger. If we were using databases that were created with MongoDB 2.6 or 3.0, the default storage engine would be mmap version 1, and then it would say, I've detected mmap version 1 files. You can only have one kind of files in a data directory, so you can't have both mmap v1 and WiredTiger files coexisting in the same directory. Then there's a warning here. You'll get this for most people that install it. Warning, soft R limits too low. Number of files is 256, should be at least 1,000. This is a warning effectively for production systems. Obviously, if you have a large number of clients, then you need to have a large number of file descriptors available to you. For development purposes, it's fine to ignore this warning, right? You're unlikely to be having thousands of clients connecting to your development MongoDB. And if you are, well, then you need to up that limit. And then it basically does a bit more housekeeping, and now it's ready to accept connections. And so now we're up and running with MongoDB. So now I'm just going to show you the shell. I'm going to switch to desktop mode and just show you the shell and show you exactly what we've got in this database. So this is the daemon I just started, MongoD. You see DB path B2B. And here's Mongo stat running. And as you can see, it's all zero. There's nothing actually happening on the application. So I'm going to open another terminal window. And I'm just going to run a Mongo shell. And you'll see a connection opening on the left-hand side on this window. And now I'm just going to do show databases. Let me just increase the size of this font a little bit so people can see it clearly. And you'll see there's a bunch of databases in here. So I've been playing around. So the one we're going to work with today is blog, right? So I can say use blog, and that switches me to DB blog. And now I can do show collections. And you see there's two collections here, articles and users. So if I do db.articles.count, you see there's a million articles in there, and I do dbusers.count. We've got a million users as well. And now I can look at one of these articles You'll just see the format there. And this is a random file I've generated. So you've got an ID, which is 0. It's the first one here. It's got a body, which is a random string of text. It's got a post date. It's got an author, which is, again, generated. And it's got a random title. And then if I show the users, db.users.find1. Again, you've got an ID, an object ID, which we'll talk about in a minute. A username, which is user0, a lang, which is a locale, en, a password, which is a random string, and I've got a karma rating, which is essentially, is this user a good guy or a bad guy? And we can see how those are used in lots of systems. So I'm just going to go back to the deck now for a second. So we've connected via the shell. We've looked at databases, and we can see that we can interactively connect to the environment. And we've looked at databases, and we can see that this database, db.demo.find1, has this strange ID object. So when I inserted it, so I show databases, then I use test, switch to db test, then I do show databases to see that there's only a local database. Then I do db.demo.insert key value. What this happens is this makes a new collection called demo spring to life in the test database. So we don't need to do any explicit create. Once we call that and invoke that collection, it springs to life. And we see a write result, which is one value inserted, this key value document. Now when we do show databases, we can see there's a test database there, and we do show collections, we see demo. Note, we didn't have to do any explicit create commands. These things just pop to life. And even though we inserted just a key value, we got this object ID inserted automatically as part of the create. So what is this object ID? Well, every document that you install or you insert into a MongoDB database gets an object ID for free. And this is a unique key on every document in your database. And it consists of a set of predefined values. So there's a timestamp. Then there's an ID field, which is typically generated off the Ethernet card of the system. Then there's a process ID, which is the process ID of MongoDB as it started, or rather the process ID of the client program when it started. And then there's a count. And that count is essentially created when the client is created, and it's incremented with each insert. And the combination of these fields guarantees that you'll have a unique ID, because the timestamp obviously increments at clock intervals as fast as the, well, in my case, the OSX clock ticks. So you would have to insert millions and millions of documents to roll over the count between one clock tick. So this object ID is guaranteed to be unique. Note, it's unique for this system, this computer here. There isn't a guarantee that object IDs won't be the same coming from different systems. So that's an important facet you need to keep an eye on when you start creating object IDs, is that object IDs may not be unique in a sharded cluster. So we're going to create a simple blog application. It's just going to be a really simple application based on the schema that's going to have users, articles, and comments. Now, if we were building this with a relational database, we'd have to get all our design done up front and do an entity relation diagram and think about all the different use cases we're going to have, and have slugs and publish dates and text, comments and authors and tags. And, you know, you've got to get it all right, because once you go into production, changing that schema is a huge nightmare, right? One of the biggest challenges for anybody who deploys their first relational database application is the time that the first set of requirements from new users comes in. We don't have to worry about that with MongoDB, because we can build organically. So I can say use blog, switch to DB blog, and even though I have pre-populated the blog database in this case, but if I had no databases, if I had no elements in this, I could just do this db.users.insert, give it a username Drumgoole and a password top secret. Do not use that as a password anywhere. This is purely for indicative purposes. And a profile of en. There we go. We've got a user in our database. And when we find one, we see we've got that user inserted, and he's got a unique object ID. Now if I inserted a second Joe Drumgoole, I'm guaranteed that there will be unambiguous ways of distinguishing between Joe Drumgoole 1 and Joe Drumgoole 2 via the ID. Now, we may want to impose a constraint that effectively the username is unique amongst users. I will show you how we might do that going forward. So how do we do this in a program? Now, I've got the code here in the deck, but again, I'm going to switch back to the screen just to show you how we do this. So here's the code for create user. So it's very straightforward. We import PyMongo. That's the client program that Python supports. This is a Python program. All of the code examples today will be in Python, but the same approach applies in Java, in Ruby, and if you're a Java or a Ruby expert, it should be relatively easy to switch between what I'm showing you and what you would do in your own personal language. So we will create the client. This creates a default client which connects to the default port that MongoDB starts on. So if you're just starting MongoDB from the command line and not specifying a port, PyMongo will set up the right connection to this client. If you want to start your server on a different client port, then you'd need to specify it here, a host and a port. And again, we just make the database spring to life. We just say blog database equals client, and then give it the name of the database, which is blog, and users collection, blog database users. So if this database and collection doesn't exist, it will spring to life. If it does exist, it essentially creates a connection to it. And then we just insert that document into the users collection, and then I can print the user. So I can run this program now. And there we go. We just print out, there's username user. It's installed and it's been installed in the application as user 0. And now I'm going to show you what that looks like on the database. So db.users.find is going to look from the front to the back. And you'll note that we've got, let me just scroll back up here. You'll see we've got a user 0 that was installed there. So we've created a user. It's been very straightforward. We can do it in the command line or we can do it inside the program. I'm now going to switch back to the deck. So there's code there that essentially replicates what we were doing here. Now we want to create articles, right? Same thing applies. It's a really straightforward thing. We're going to do something in articles here that is essentially a validation check. So I know in my blog application I want users to be unique, right? So what I'm going to do is I'm going to find the author and insert there. And if the author doesn't exist in the database, then I'm going to raise a value error because I know every author has to exist already. So this is a validation check that essentially says when I insert an article, the author name that I insert in there must already exist in the database. So this stops us creating articles which we don't have authors for. And this is one of the ways in which we do that kind of foreign key constraint. We just put it in the code. And of course, because this is MongoDB and we have dynamic schema, we can now extend the schema of this object, right? So we're going to add a new article with a post date, which essentially tells you the date that the article was created. And we're going to add a new section, technology. You'll see those two here. So there's the section, and here's the post date. So now what we can do is we can effectively create the article and then just insert it into the articles collection, again checking if username is a valid author. So now we've got articles collection.insert1 down here. And we've got a post. So now we've got a user and we've got two kinds of articles installed. So now we've got another program here which I ran earlier on, which I'm going to show to you, which essentially creates a large database of users. It creates over 1 million users. And so what I'm doing here is effectively I'm going to make an article. This is a prototype which takes in an argument of account, an author, and a timestamp. I'm going to make a user, which takes in effectively a username. And then what I'm going to do again is I'm going to connect to the blog database. I'm going to connect to the users collection. I'm going to connect to the articles collection. And then I'm going to use something that you will find very useful as you start to scale out your use of MongoDB. We've got this capability to do what we call bulk uploads. So we can use the bulk upload API. And effectively what we do is instead of inserting records one at a time, we add them to a bulk uploader object. And that bulk uploader object will upload those articles in bulk. This reduces the number of round trips to the server. And so typically with the bulk upload API, so essentially we initialize bulk users and bulk articles. We initialize a timestamp here. You can see it here. There's the timestamp. Then we're going to essentially iterate for 1 million records. We're going to add a user, which is created from the account. We're going to add a username from the make user function. Then we're going to add an article, and we're going to increment the date stamp by a second each time so we can differentiate the articles. And then every 500 articles, we're going to essentially bulk upload the 500 objects we've created. And this has the effect of essentially taking even my laptop from doing about 1,500 inserts per second to doing about 15,000 inserts per second. So this is definitely something you should look at. And then because this is a mod function, we actually have a bulk users execute at the end, which just cleans up all of that data. So now we've got a database, as I showed you before, with over 1 million articles in it. I ran this before I started the webinar because effectively this is going to take a long time to run. So now we want to find the user. So we call db.users.find one, and we see this prototypical user with the object ID, the username, the lang, password, and karma. Karma is a score between 1 and 500, or 0 and 500, that rates a user's effectiveness. So if they're commenting or if they're putting in more articles, they obviously get higher karma. And then we can look at the specific user. We can call db.findUsername to find an individual user, and that's essentially doing a query based on username equal to this VHXD horrible random string. So this is essentially a lookup on the database over here, this piece here. Now, what if we wanted to find users with a high karma? Well, we can effectively specify greater than over here by saying db.users.find karma is greater than 450. The .pretty is just an annotation in the shell that essentially pretty prints the format for output. And now what we'll see is a whole bunch of users with a karma value over 450. And this is exactly how we do queries in MongoDB. We've got this JSON-based programming language with the ability to do range-based queries, the ability to do selection queries, to do regular expressions, to do and or not. So, I mean, there's a long set of documentation on this. I'm not going to take you through every format. The key thing is to understand that it's a rich query language. You can do all kinds of interesting queries on your data. So here's another aspect of the query language. We can do a find, but we can use projection to limit the set of fields that are returned by the database query. So over here is the projection field. You can see it. I'm just underlining it now. So you can say, I want to see all users with a karma score greater than 450, but I'm suppressing the ID field. I don't need to see the object ID, and I'm only including the username and the karma field. So this is done on the server and obviously reduces the amount of network traffic we get back and give you a much more easy to read set of data, or limit the set of data that gets thrown over the network. So now, let's update an article to add comments. So we find the article ID 19 that matches the 19 ID, and this has a random body as before, a random post date, a random author, and a random title. And now what we're going to do is we're going to update this article. So we're going to do db.articles.update, again with ID 19, and we're just going to set a new field. This is the way that we do updates in MongoDB, or one of the ways. So we're going to add a field, comments, which is an empty array. And we'll see at the end the right result. N-matched is 1, we found one document. N-modified is 1, we've changed one document. And upsert would be, we can choose to say, if an update is to a document which doesn't exist, we will insert that document. This is not an upsert because we're updating an existing document that we know is in the database. Now we're going to add comments to that. So we can see, if we look at the data now, we've got a new field in here in red, the comments field, and it's an empty array. So next step, how do we add a comment to this document? Well, again, we've got db.articles.update, the ID is 18 as before, and we can append to this array a comments document. Now, it was an array up to now. We hadn't really defined what was going to be in the array, but now we realize that these comments are going to actually be sub-documents. They're going to have two fields, a username and a comment. And of course, we could add post dates in here in the future. We could add images. We could add thumbnails. The key thing being we're building the schema organically. That's the power of MongoDB. So we've gone from users to articles to enhanced articles with sections, and then to articles with comments, and to comments which are nested documents containing their own structure. And we can then delete an article. The remove function will again match on the ID, and we can delete one article if it's just, we know there's only one article with ID 25 because that's the way I built the original database schema. But I could also remove multiple articles. So here I want all articles with an ID less than 5. And because we counted the articles from 0 onwards, that's going to remove 6 articles from the database. Obviously, you want to be careful with this. If you get that specifier wrong, you could delete a lot of data. So often it's worthwhile when you're playing around with the data to do a find first. Once the find gives you the results you want, then run the remove. It's key to understand that deletion can often leave holes in the database, so it may often be cheaper to drop a collection rather than deleting a large collection element by element. So if you've got 1 million records and you're deleting 900,000 of them, I would copy 100 elements to a new database collection and drop the original collection. So let's look at articles again. We've got this find one, which is the ID, username, lang, password, and karma. And then the articles looks like this. Now, supposing I find the user in this 1 million element array. Well, let's see how efficient that is in our current structures. So db users.find, username is this random string, and I'm going to use explain. So explain is essentially our query analyzer. And the query analyzer will tell us a whole bunch of information. But the most important information that this particular explain reports is if I look at the red line text, the stage, that col scan tells me that I'm doing a column scan or a collection scan, effectively a table scan of this whole collection to find this element. And so now I'm going to look at it and say, well, let's have a look into what happens when we do that column scan. So we essentially add an argument to explain, which is execution stats, and I'm just selecting the execution stats sub-object from that. And we'll see here the execution time to complete this query is 433 milliseconds, and that's a long time for MongoDB. That's nearly half a second. And we'll see why. Because it examined 1 million documents. That's what happens in a table scan or a collection scan. It has to look at every document to see if it's a match. And so you can see the query engine built an execution stage, which was a column scan or a collection scan, and it estimated that the execution time would be 330 milliseconds, and actually it was much worse than that. And again, you can see in this execution stage at the bottom, the docs examined was 1 million. So that's obviously pretty inefficient. Well, the natural way to fix these challenges is to create an index on username. And we can do that with this simple command, db.users.createIndex, username 1. this creates the collection automatically. It's not creating the collection. You'll see that the number of indexes before was 1 because there's always an index on the object ID. The number of indexes after is 2, and everything worked out okay. Now we have an index on the username. One of the things we can do with indexes is we can ask it to build them in the background. When you're building an index on a very large collection, it can take a long time. Now, on this collection of 1 million records, it takes a couple of seconds to build. But that's because I've got SSDs and not much else is happening on this machine. If you had a billion records, it would take a long time. So you can force the server to do this build in the background so it doesn't block your database from access. You can also demand that it be unique. So for instance, if I made this a unique key, then if I inserted Joe Drumgoole twice, it would reject the second insert. And that's often a valuable way to give you some kind of control over what's inserted. And then I can name the index. So the names are auto-generated, but you might want to name the index explicitly. The delete of an index is the exact opposite of the create. You just do db.users.dropIndex and specify the same pattern as the index. And you can see all the indexes on a collection by doing db.user.getIndexes. Within the query planner, the explain plan, there are 4 kinds of stages you should look out for. Call scan for a collection scan. That means I'm going to look at every document in the collection. Index scan, which I'm going to show you here, which says I'm going to use an index to service this query. Fetch, which essentially says I'm going to use an index and I might have to do more than one index scan. And then shard merge, which I'm going to talk about in a subsequent webinar, which talks about how we merge data when we're querying across multiple shards. We're not going to talk more about this today. So now that we've created the index, let's look up this user again, user 9999999, which is quite near the end of the session. So let's do explain and show execution stats again. Immediately we see execution time millis has dropped to 0. This has effectively become so fast we can't measure it anymore. And look, we only examined one key and one document. So surprise, surprise, it was virtually instantaneous, and this is the power of an index. And we'll see if we look at the execution stages, the stage is fetch, which tells us we're going to use an index, and then we see the stage index scan returned 1 document, and again the action time millis estimate was again 0. So what we're seeing is a dramatic improvement from 433 milliseconds to nearly 0 milliseconds. So obviously things get a lot faster. So when you're building your applications, understand that you can create your schema on the fly. Understand that you can arrange and reset the document contents on the fly. But when you want to create queries that are performant in large data sets, you must create this index on your collection. You can have multiple indexes on a collection. You can have indexes on every field. But remember, indexes are just like indexes in a relational database. There's a cost to indexes. When you update or insert, you have to update the index. If you've got 10 indexes, that means 10 write operations rather than 1. So don't go crazy with the indexes unless you know what you're doing. Generally, a well-tuned MongoDB collection should have about 1, 2, maybe even 3 database indexes. Now what we've shown you today is the JavaScript and Python interfaces. JavaScript is what's used in the shell. Python is what's used on the applications I've shown here today. We also support Ruby, Java, Perl, Microsoft.NET and C#, PHP, C++, C of course because MongoDB is written in C and C++, Scala, Node.js, and a host of others. These are the supported drivers you can download from MongoDB today. And we are supported by a range of frameworks. The mean stack, the M in the mean stack is MongoDB. That's MongoDB, Express, Angular, Node, and Node.js. Angular, Hibernate, Spring, all support MongoDB. But I would caution you, don't get stuck in the trap of using an ORM because effectively you don't need it anymore because you can dynamically change the structure of the documents already, so you don't need a mapping layer. A mapping layer is when you need to map an object into a table structure. So be aware of things like Hibernate, Spring, and Morphia. So what have we learned today? Well, how to create a database and a collection, how to insert content into that collection, how to query that collection in a range of different ways, how to update a document in place, and how to delete a document. These are the standard CRUD operations we expect every database to have. How to check the efficiency of an operation. When things start to slow down, explain should be your first port of call. Pull that query out of your code, put it into the shell, take a look at what's happening. You can run explain inside your drivers as well. So if you've got a deeply nested query, you can append an explain operator to it and see that output coming out into a log file. Once you know that you're doing an operation a lot and it's inefficient, that's the time to look at adding an indexes. Indexes are trivial to add and will have dramatic impact on the efficiency of your queries. And once you're using that index, once you've deployed that index, make sure the index is being used. Use explain again to make sure that you can see that the index is being used. So that's the end of the spoken part of today's webinar. We're going to continue to remain online for the next 15 minutes to answer questions. I just wanted to give you a quick preview of what's coming up next. The next webinar is Thinking in Documents. If this webinar was about getting you up to speed on how to interact with the database pretty much as you've done before in a relational database, the next webinar is about changing your mindset, getting you to understand that working in MongoDB is very different from working in a relational database, understanding that normalization is not the first answer in getting efficiency out of your database, understanding that a more coherent mapping between your objects and the application, objects in your database and your application will make more sense for you, and then optimizing around the queries you intend to make or the write patterns you intend to see. Finally, we show you that dynamic schema isn't the only game in town, and we have a schema validation capability in MongoDB 3.2 that allows you to impose some level of discipline over what your developers insert into the database. That'll be running in a couple of weeks' time on the 14th of June 2016 at 2 o'clock, again, GMT or British Summer Time if you prefer. Okay, my colleague Ruben has been answering questions as we've been working through this. So a big thanks to Ruben for pitching in there. I'm just going to have a look at some of the questions that are left here. Is there any limit to the schema that can be added in a document? Yes. First of all, the most important limit, Samrendra, is that documents can only be up to 16 meg in size. So you can't grow a document without bound. So we always say grow your database by adding documents. Don't grow your database by increasing the size of documents. So that's the key limit. There are a range of other limits around key sizes and values, which are pretty large. I don't think most developers are going to come across them. But again, if you go to our docs page, you can see what the limitations are on that. So Claire Marchand asks, is there a way to control when an index gets updated? No, an index is updated and has to be strongly consistent, which is a key pattern of ours, every time there's a write operation. So if you're creating a new index, there are a range of ways you can modify the index to make sure it's more efficiently updated. So the first way is, if you're using a replica set, you can build the index on each replica offline. So you can take a member out of the replica set, build the replica set offline, and then add it back into the replica set. So essentially, if you're adding a new index, you don't have to take the whole replica set offline. Or you can run it in the background. Now, a background index build is still going to impose a pretty heavy load. I would recommend for any production deployment, you use the replica set model, and you take out one element of the replica set at a time to build new indexes. Is it that and Claire, yes, is it that every write will affect a write to an index? If you're writing to a collection and you're updating an element that has an index in it, yes, you will update the index. This is exactly as it is in relational databases as well. Venkata Vishwanath Reddy asked, when using explain with aggregate functions not getting info about runtime, what could be the reason? Because you're probably not using the execution stats parameter. So when you call a query with just plain.explain, it just gives you the basic query parameters. You actually have to pass in a string execution stats. That's all lowercase but uppercase s on the stats. And that will give you the detailed information. Nirmal Jain says, how do we restrict the user to use DB? Any security on MongoDB databases? Yes, we have a full security package including access controls, audit, and authentication and authorization. I haven't talked about that today because this is in the introductory course. There is a range of webinars available on our webinar page talking about high-level security, and we also have a white paper which talks about how you can secure your MongoDB database. And absolutely, we want to see everybody doing that before they move into production. So I would recommend you look at the white papers and the other webinars on how to secure a MongoDB database in Irma. Dinesh says, so by default, data stored in the same case if we enter data. That's a follow-up question to Ruben. I'll let him cover that. Amitesh Sinha, do we need to apply CAP theorem in choosing which NoSQL or database we want to use? Yes, you do. So CAP theorem, for those other listeners here, is from Eric Brewer. It stands for consistency, availability, and partition tolerance. And what Eric Brewer said, and which has since been proved, is that in a distributed database, you can have any two of these properties. So consistency, everybody sees the same view of the data. Availability, you can always write. And partition tolerance, you can survive a network partition. So we are a CP database. We focus on consistency and partition tolerance. That doesn't mean writes won't be available, but in a situation where you have an election, where a node of a replica set failed, there may be a brief period where writes will be rejected by the client. So that's why we call ourselves a CP database, Amitesh. Alistair White, how does the insert restrictions user must exist when inserting an article work with bulk transactions if it's done within the code? Alistair, if you insert in a bulk transaction and you breach the unique key constraints, the bulk insert will fail. And in that scenario, you will have to check as to how many records were inserted before the failure occurred. It's one of the challenges when you use the bulk insert API. So yes, it will fail, and you'll need to look at the error codes to see how many records were written, and then you will have to look inside the database to see what the level of consistency is in terms of the number of records that were written. Anurag Gautam, what is the size of each document? You can calculate this by looking at the BSON types and actually writing a document and dumping it to a BSON file. It's roughly the size of the document as you see it, plus the size of the labels, plus some header information which gives you type and size information. So a document will always be slightly bigger than you'd expect it to be because of that additional overhead. But again, you can ask the driver to tell you what the size of the documents are. Silpa Jain, what is Wired Tiger? Sorry, Silpa. So there are two storage engines you can choose when you're deploying MongoDB. In 3.2, the default storage engine is Wired Tiger. It's the company we acquired about a year and a half ago. It's a very high-performance, write-focused storage engine. Our previous storage engine, mmap v1, which is still available, was for more balanced performance, but more read-focused than write-focused. So for anybody downloading 3.2, WiredTiger is the one you'll get by default, and if you're doing new development, that is the one we recommend that people use. However, for existing customers who have built applications on 2.6 using mmap v1, we give them a migration path where they can move to 3.2 and choose the old storage engine. Rakesh Sharma says, can we store small video? Yes, you can. So you can binary encode data and put video segments up to 16 megabytes in the database. However, we have a capability I haven't spoken about today called GridFS, which is essentially designed to help you store very large binary objects. So video at any size, say DVDs or audio streams or large raw image files, can be stored in GridFS, and it automatically partitions the file into 16 meg chunks so that you can efficiently manage large binary blobs inside the database as well. And again, you can look at the GridFS documentation online to see more about that. Saravangan Ramalingam, how to enable security to collection. Again, look at our documentation on security in MongoDB and the white paper. There is a range of capabilities. You can add users, you can constrain who is authorized to access the database, you can constrain what they're authenticated to do, and you can constrain and understand what operations are happening by using our audit capability. And we support Kerberos and LDAP to improve that security. Brett, who didn't provide his second name, are there tools to help determine where indexes will improve performance based on use? Yes, there are. Our Cloud Manager hosted environment and our Ops Manager on-premise environment, these are tools that you have to pay for, will give you predictive analysis and recommend where you should apply indexes in your application based on the performance of queries in the application. So look at Cloud Manager initially, Brett, and then if you want to do the same thing on-premise, you can look at our Ops Manager product, which essentially allows you to do Cloud Manager capabilities on-premise. And there's a visual query profiler and a query recommendation engine. Jason Haynes, does MongoDB have a transactions-like a relational database? No, it does not. Transactions are on a single document. If you want to do multi-document or multi-collection transactions, you need to build it in your application. It's very hard to build multi-document transactions in a performant way on a distributed cluster. So, no is the answer. You can build multi-document transaction capabilities by using the fact that we are transactional over a single document in terms of rights. Can we create, Durga Prasad says, can we create this blog application directly from the MongoDB command line rather than using PyMongo? Yes, you can. And in fact, historically, that's what I've done, but I thought we would introduce a real app programming application just to give an example of how we do both in parallel. So yes, you absolutely can do it just using JavaScript on the command line in the Mongo shell. There's no reason not to do that. Obviously, ultimately, real applications aren't written in the shell. They're written in a programming language, and I think at some point you'll want to move to one of our drivers, Java, Scala, Ruby, Python, Perl. My own personal favorite is Python, but there you go. So I'm going to get to a few more questions before we wrap this up. I've got about 5 more minutes, so I'm going to cover as many as I can. If my collection, Bharatharaja says, if my collection can have 25 million entries, how do I make the query faster without indexes? Well, you could try and keep it all in memory, or you could put the collection on SSDs, but you're really down to the case that you're going to have to either make the infrastructure faster, make the program faster, or you could effectively run multiple clients if you could partition your data on a key and then essentially start the searches at different points in the collection. But remember, even to start, at, say, entry number 5 million and do that 5 times to give you partition searches. You'd have to know the way that the object ID was sorted on the collection. So you could use the temporal element of the object ID, which is already indexed, to partition the collection and then do the searches in parallel. But that's a lot of work. Why would you not just create an index on the key that you're willing to search on? Radoslav, is there any way to fetch the document added most recently? If it's in an index, then obviously you can just use a timestamp. If you want the most recent document, we have a capability called a capped collection, which effectively gives you a round-robin storage capability to give you a fixed number of documents, and you can use what's called a tailable cursor on a capped collection to essentially get the last update, the last document that was added. So that tailable cursor will give you that capability. So if you look up capped collections on MongoDB's documentation set and tailable cursors, Radoslav, you'll be able to see that. Vishnu Ganesan, can we limit the number of keys per document in MongoDB? No, you can't, but you shouldn't be creating indexes at random anyway, and that's more of a programming discipline question than something that we can impose with MongoDB. You could set up your users so that they didn't have authorization to create indexes, and so you can do it that way, but that requires you to set up a reasonably complex authorization and access control model. But that would allow you to limit what operations your users could do. Tamas Trexenel, is there a way to deploy MongoDB with my program, a kind of portable version that I could use like a database file, or do I have to have it pre-installed on the target syslan? Well, you can take MongoDB and bundle it with your application, Tamas, and start it every time you want to run the application. That's a perfectly acceptable model of operation. And in the open source version, there's no constraints on doing that because your access to the database is through an Apache licensed driver. So it doesn't impact delivering a commercial version of the system. However, if you want to use some of the commercial capabilities like Cloud Manager or an encrypted storage engine, you'll have to talk to us about a commercial license. But you absolutely could run the MongoDB daemon locally inside your application or alongside your application when you started it. Anup Valiapurali, what are the typical day-to-day activities of an administrator or DB at MongoDB? The same as an administrator or DBA of a normal database. Setting up databases, setting up collections, managing storage, looking at the performance of the system, controlling access, granting account access, setting up audit logs, looking at the overall management capabilities of the large cluster. The experience of managing MongoDB is very similar to managing a cluster of Oracle or MySQL Server. So yes, you should see yourself doing and engaging in the same sorts of activities. Okay, I'm going to be able to answer a couple more questions and then we're going to wrap it up. I would recommend to people to sign up for the next episode in the webinar series, and if you've got any other questions, email backtobasics@mongodb.com. So I'm just going to hit one more question. Lee Gambrill says, hi, is there a way to find long-running queries with no index? Thanks. Yes. You can specify a parameter to the daemon when you start it to flag queries that are running for longer than 100 milliseconds, and in fact you can change that value. So all queries that run for longer than 100 milliseconds will be flagged to the log file for the MongoD. That was the series we used earlier on. I showed you starting the daemon. So if you have that log going to a screen, you'll see that log being flagged. Last question from Victorio Monileo. Is there any free graphical tool to see the performance of MongoDB queries? Yes, there is. You can use our Cloud Manager hosted tool. It's not free, unfortunately. Or you can use, like I said, the long-running queries capability in the log file to actually look at that. Okay, folks, I'm going to wrap it up there. I'd like to thank everybody for joining today. Thanks for all your questions. What questions we didn't answer today, we'll answer via email in the next couple of days, myself and Ruben. I'd like to thank Ruben for helping out today, and of course Sam, our behind-the-scenes man, who makes all of this work and makes sure all of you get the right information in your run-up to the webinar. Look forward to seeing you all in a couple of weeks' time for the next webinar, Thinking in Documents. Thanks very much for your time today. I hope you had a good time. If you did, tell me, and if you didn't, tell me as well. Bye now, everybody.